So before we look at factorising a cubic using long division, let's just revise long division with numbers. So let's say I want to find out how many times does 4 divide into 300. So we set up our division. We start by saying how many 4's go into 3. We know that's 0 times. So using that 0 we put at the top, 0 times 4 is 0. So taking that away, we have a remainder of 3. Let's bring down the 0 next to it. 4 times, let's have a look from this point. How many 4's go into 30? Well, 7 4's are 28, but 8 4's are 32, so it's going to be 7. So 7 times 4, we've used 28 of the 30, so if we take that away, we have a remainder of 2. Bringing down the next value, looking from here, how many 4's go into 20? Well, 5 4's go into 20, so 5 times 4 is 20. Taking that away, we've used all the values with a remainder of 0. We have our answer of 75. Let's consider the short division we would have normally done with the 300. So 4 goes into 3 0 times, so we carry the 3. 4 goes into 37 times with 2 left over, and 4 goes into 25 times with nothing left over. So we can see that this 30 that we've got here in our long division is the value we've made here, and the 20 that we've got is here in our long division. So it's just actually showing the thought processes and the calculations we're doing. Let's try one more. Let's find out how many times does 15 divide into 1950. 15 goes into 1 0 times, so 0 lots of 15 is 0. Taking away the fact we use nothing, we have the 1 still there. Let's bring down that 9. Looking at this point, 15 goes into 19 once, so 1 lot of 15 has been used, so we've got a remainder of 4. Bringing down that 5. Looking at this point, 15 goes into 45 3 times, so 3 lots of 15 is 45. We've used everything, so bringing down that 0, 15 goes into 0 times, and we have our value of 130. So let's see if we can actually complete this with a cubic. So first of all, we need a factor to divide into it. Looking at this first one, x cubed plus 3x squared plus 3x plus 1, I'm thinking to have a value on the end of 1, I'm going to have a factor of 1 or negative 1. So let's go for a factor of negative 1. So if we substitute this in, we get negative 1 plus 3, take 3 plus 1. That does give us 0, so x plus 1 is a factor. So let's use this. So we want to find out how many times does x plus 1 divide into x cubed plus 3x squared plus 3x plus 1. So we're going to use the same process as the long division with numbers. Because we've got 2 terms out the front, we're going to have to essentially look at 2 terms at a time. So I'm going to concentrate on these 2 terms first. I like to concentrate just on the first term and the x, because I'm going to divide the x into that one first. So I'm essentially saying to myself, how many times does x go into x cubed? And that will be x squared times. And we know that because when I multiply down the x squared times the x, that'll give me the x cubed. And essentially I'm just trying to work out if there is a remainder. So now the x squared times 1 will be plus 1x squared. And now I'm going to take this away because that's what I've actually used the value of. So now I'm going to take this away and see if there's a remainder. So x cubed take x cubed is nothing. 3x squared take x squared leaves 2x squared. Let's bring down our next value, which is plus 3x. Okay, so let's see how many times does x go into 2x squared? Well, that's 2x times, because 2x times x gives me 2x squared, and 2x times the positive 1 gives me positive 2x. So I'm going to take this away. That's the value here that I've actually used, using the 2x. So what's left? Well, my 2x squareds have gone, and 3x take 2x leaves me with an x. Let's bring down the plus 1. We've got our two terms with two terms. Something very nice that we see here. X goes into x one time. So one lot of x is x and one lot of 1 is 1. Take that away and we get a remainder of 0. So that tells me that so far in factorising this cubic, I've got x plus 1 as a factor and x squared plus 2x plus 1, which I can factorise that quadratic to find my factors, and in actual fact they're all the same, so I can write it as x plus 1 all to the power of 3. So let's try that one more time with our second example. We've got x cubed take 7x squared plus 16x take 12. So I'm thinking, looking at the number 12, negative 12 on the end here, that's made up by the three values that get multiplied at the end of the brackets. So I'm thinking that it's got to be something like 3 and 4 and 1, or 6 and 1 and 2, or something like that. So I'm going to try, when the function at 2, when x is 2. So I've got 8 take 28 plus 32 take 12. So I've got negative 20 plus 32 is 12 take 12. Okay, excellent. So x minus 2 is my factor. So let's see if we can do some long division. So let's set it up. Okay, x goes into x cubed, x squared times would be left. And I can see now that x squared times x gives me x cubed, and x squared times negative 2 is negative 2x squared. Let's take that away and see what remainders we have. So we've taken care of the x cubed. We've got negative 7x squared plus 2x squared. So that's negative 5x squared. And we're going to bring down that 16x. So everything's kept in the columns. So now I've got two terms. I'm going to say how many x's go into negative 5x squared. So that's going to leave negative 5x. So negative 5x times x is negative 5x squared. And negative 5x times negative 2 is positive 10x. So taking this away, my x squared has disappeared. And 16x take 10 leaves 6x. I'm going to bring down that negative 12. X goes into 6x positive 6 times. So 6 times x is 6x, and 6 times negative 2 is negative 12. Taking away this, I'm left with a remainder of 0. So this makes me very happy. So this can tell me that I know x minus 2 is a factor, and I'm left with the quadratic x squared take 5x plus 6. So I can factorise this quadratic. What multiplies to give 6 adds to give negative 5. I've got 3 and 2, so I could do negative 3 times negative 2 is positive 6, and negative 3x take 2 is x is negative 5x. And what I notice, I've got a repeated factor, so I can write it as x minus 2 squared, x minus 3, and I factorise that cubic. So the more times that we use the long division, the better we have an awareness of how to work it out. But basically, every time we're taking away and finding the remainder, we're finding that these are disappearing down to 0. Okay, and I use this x as sort of my leading sort of check value. But let's consider now another option. If we don't want to use inspection, which is very logical, and we don't like the long division, there is another very quick way to look at this, and it's called synthetic factorisation. I call it the shortcut factorisation. How do we factorise a cubic? And basically it's just a process that we can use that works really nicely. But first we need to know a factor. So from our first example, we use the factor that f when x is -1 gave us 0. So x was -1. So we're actually going to use x as -1. And we set it up as follows. We draw this little sort of factor box here, and I put my factor on the left, and I write the coefficients of my cubic across the top. Okay, now what we're going to do is make sure we bring that 1 down and place it at the bottom. Our next task is we're going to use this value x as -1, which we know is a root for our cubic, and we're going to say -1 times this value 1 is -1, and we're going to place that under the 3. Now we're going to add this column. 3 and -1 leaves 2. Now we're going to use that -1 and multiply the 2. -1 times 2 is -2, and then add this column. 3 plus -2 leaves 1. And lastly, we're going to get this -1, and we're going to times it by our value of 1 here. -1 times 1 is -1, and when we add our final column, we should get a remainder or a value of 0. And this tells me that I've finished my synthetic factorization. So knowing that x equals -1, my factor is x plus 1, and then I'm going to use my solution here at the bottom of my factor box as the quadratic that I have left, which is 1x squared plus 2x plus 1. So these are the values of a, b and c of our quadratic. And now I know I can just factorize my quadratic and simplify where necessary. And I factorized that cubic. Let's take a look at that again. Let's go back to our second example. We used the function at 2, so when x was equal to 2, and we found that this equaled 0. So I'm going to use x equaling 2. So in this example, remember we're going to draw this little factor box. We're going to put our factor of 2 at the top on the left. So we're using x equaling 2 as our root, and we're going to put the coefficients of our cubic across the top. Straight away we're going to drop that first value, because I know that with x cubed, that if I take out a factor, which here the factor would be x take 2, the remaining quadratic is going to start with x squared, because it's the only other thing it can be, because the coefficient in front of the x cubed is 1. So I know that this here is my x, makes me have 1x squared. So I'm going to just drop that value straight away. Okay, so 2 times 1 gives me 2. Let's add -7 plus 2 is -5. The 2 times -5 is -10. 16 plus -10 is 6. 2 times -6 is, 2 times 6 is 12. Adding that column, -12 plus 12 is 0. I am happy because I've got a 0 there. So now what we've got our quadratic across the bottom, and we had x equaling 2, so my factor is x take 2, and my quadratic 1x squared take 5x plus 6. Exactly the same as what we got when we used long division. So I can then factorize that quadratic and then simplify my factored form where necessary. So now what I want you to have a go at is going back to our worksheet and seeing if you can try long division for one of the examples, and then try the synthetic factorization as well. You can use your class pad to check by going into main and saying action, transformation, factor, and see if you can get the matching solution. The solutions to the worksheet are also on this week's Connect, so you can easily check your answers. The worksheet gets quite heavy with the algebra. So after you've tried a few where you've done a bit of long division, you've tried some doing the synthetic factorisation, what I'd like you to do is go back to exercise 7A, questions 5 to 8 in the Sadler textbook, and they just go through mainly the use of inspection. So that's a great way to try that. And then if you're ready to practice some algebra manipulation and some more of these different ways of factorising a cubic, have a go at finishing that worksheet.